All right, guys, let us look into another question. This is going to help us again to recap what we have done on our derivatives from the first principles and also using the general rule. So we've got question number 9 that you're going to use, and that's 12 marks. All right, so 9.1, determine the derivative of f of x, which is x squared plus 3x from first principles. All right, 5 marks for that from first principles. Remember your first principles formula as you are given it from the formula sheet, the first derivative from your information sheet. That's limit as h approaches to 0 of f of x plus h minus f of x over h. So this is what we are going to use. All right, already f of x is given, so what we are going to need is f of x plus h. F of x plus h, substitute x plus h where there is x. So x squared, x plus h squared, plus 3 into x, x plus h in place of that. All right, remember this expansion, guys, of a squared. We've already done this. It's going to give us x squared plus 2xh plus h squared. Then we expand the second bracket by what? By positive 3. Positive 3 times x, positive 3x. Then 3 is going to multiply h, which is positive 3h. So we do not have like terms here. So that is our f of x as it is. Substitute into the formula. Then you can simplify further. So that's it. The limit as h approaches to 0 of what? This whole part. X squared plus 2xh, h squared, 3x, 3h, just like that. Minus what? F of x. So I'm just going to put this in a bracket since we have got an expression x squared plus 3x. Then what am I going to do? Expand the brackets definitely, then collect the like terms so that we can simplify our limit as h approaches to 0. So just rewrite this part as it is 2xh, h squared, 3x, 3h. All right, negative multiplies, yes, gonna be negative x squared. Negative times, yes, gonna be negative 3x. Then, done. I'm just gonna utilize the like terms. X squared minus x squared cancels. 3x minus 3x cancels, all right? So that is the whole idea there. Positive 3x minus 3x. Those are the like terms. The rest just gonna remain as it is from this part. So meaning to say, I'm going to remain with 2xh plus h squared, all right, plus 3x, plus 3h, I mean, everything over h. So we can separate these terms. There are 3 of them. You can do that separation, each and every part over what? Over h, right? H squared over h, 3h over what? Over h. So this is going to cancel. That's 3. And this is going to give us h. And this is going to give us what? 2x. It is up to you. Or you can just factor out the h, which is common from the 3 terms in the numerator. So factor out h. That's 2x is going to remain h. 1 is going to remain h. And h is going to cancel. That's positive 3 over h. So this is it. And this h and this h is going to cancel. Thus, we can use our limit when it is like this. Our limit can what? Can be applied on 2x plus h plus 3 as h approaches to what? To 0. It means where there is h, put a 0 there. So that was going to give us 2x plus what? 2x plus 3. All right, 2x plus 3. We cannot put anything on a 3. It's a constant. So that's our first derivative, guys. That is what you are going to have at the end with respect to what? With respect to x. All right, let us verify from the general rule, if this is actually correct, from the general rule, we do understand that we can differentiate straightforward this by dropping the power here, then subtract 1. So it was going to be 2x to the exponent of 1 plus 3x is a linear, so you just take the coefficient of x, which is 3. So that's it. It was going to be 2x plus 3. Exactly the answer that we obtained from first principles. So just use the general rule to prove your answer if it is correct. All right, let us move on to another part. Evaluate these. The first part, dy dx. If y is equal to this, we are supposed to determine the derivative of y with respect to x. 3x squared times the cube root of 8x to the exponent of 4, like this. All right. Remember what we need, guys, is the format ax to the exponent of n so that we can differentiate. So what is it that we can do? We can see that we have got a cube root here. So we can determine the cube root of these two terms separately. The cube root of a times b, let's say it is a cube root, it is a square root, whatever that you're given. The cube root of a times b, it is the same as the cube root of a times the cube root of b. You can separate as they are two terms as the cube root of 8 times the cube root of x to the exponent of 4, where the cube root of 8 is what? Is 2. Then you're going to multiply to the cube root of what? X to the exponent of 4. Remember, guys, that the power in our case is what is going to be our numerator. The number in the root is our denominator. So it is going to be 4 over what? Over 3. That is 4 over 3. Power is our numerator. All right, where is it that I wrote this? I said here, sorry, here. Here on this one, sorry for that. Here. The power is our numerator. Then the root is our denominator. So this is what you're going to have. 2x, 2 times this. So that's 2x to the exponent of what? 4 over 3. This is what you're going to get from this one. The cube root of 8, we know it. So here, guys, we can multiply. As we can see, it is a product that you have. So you can multiply 3 times 2. 3 times 2 is going to give us 6. These are same bases. Same bases you're going to add. Since you're multiplying, you're going to what? You're going to add the exponents m plus n. So that's you're going to add 2 and 4 over 3. X to the exponent of 2 plus what? 4 over 3. Same bases. So 2 plus 4 over 3 is going to give us 10 over what? 10 over 3. So that is it. That is what you're going to have here to the exponent of 10 over 3. So we have simplified this into a single term, ax to the exponent of n, where we can what? Differentiate properly. Before it was impossible. Now it is easier. We can differentiate. So dy dx is what? Remember, when it is like this, you drop the power, you subtract 1. So that's 6 times the power 10 over 3. That was going to give us 20. If you simplify this properly, you subtract 1 on the power. 10 over 3 minus 1. So 10 over 3 minus what? Minus 1 is going to give us 7 over 3. So that's to the exponent of what? 7 over 3. We have got our derivative. Just like that. We have our derivative. So it's all about revision, guys. It's all about revision. Let us do as many questions as we can. Just try to figure out from what you're given. Use your laws of exponents where they are applicable, this and that. All right, 9.2 to find the first derivative from f of x, which is x cubed minus 5x squared plus 4x, everything over x minus 4. Remember, from the fractions, I said when you are given fractions, it's either you can separate or you can factorize. So this separation cannot work because we do not have a single term. So we are going to apply factorization of what? Of the numerator. You must factorize the numerator. All right? There is x, there is x, there is x. X is the highest common factor. So let us factor that one first. X factored out x cubed divided by x is going to give us x squared. Minus 5x squared divided by x is going to be minus 5x. Here we're going to cancel x and x, so we remain with what? Positive 4. Everything over what? Over x minus 4. Still, as we factored out the x, we do not have any common term that we can cancel out. So let us consider this quadratic here. Let us factorize this. The coefficient of x squared is 1, so we're just going to have two brackets x into, we're going to have two brackets x here. All right, so considering the factors of what? 4, or the products of 4, which will give us a negative 5 when we add them, the middle term. That's the coefficient of x there. There is 4 and 1, but when we add, this will give us a positive 5, not a negative. So let's put a negative, negative 4, negative 1. If we multiply, we are going to get a positive 4. When we add, we are going to get a negative 5. So these are the ones that we need. Negative 4, negative what? Negative 1. So that's it, guys. We have managed to factorize fully. And by doing this, we can see that the x minus 4 in the numerator is the same as this one in the denominator. So these ones can cancel out. So it means our f of x at the end was going to be x into x minus 1. Can we differentiate like this? We have brackets, so we must expand. For brackets, you must what? Expand. Yes, we have applied that factorization, but now we are left with brackets. So let us expand this so that we can factorize properly. So here we're going to expand our brackets, distribute by x throughout the bracket. X times x, that's x squared. X times negative 1 is going to give us negative x. When we have got this, we can differentiate properly. That's the first derivative with respect to x is going to give us what? Drop the exponent, subtract 1. So 2 times 1, that's a 2. X, 2 minus 1, that's 1. So x to the exponent of 1 is same as what? X. The derivative of minus x, this is same as minus 1x. So the coefficient of x is what? Negative 1. So remember, a linear, you take the what? The coefficient of x. The derivative of ax, a linear, is what? Is a, the coefficient of x. So in our case, it was negative x, negative 1x. So the coefficient is what? Negative 1. So this is your final answer, as you have got the derivative. You have the what? The derivative of that. This is your derivative with respect to x. Simple like that. So you see, guys, it's all about revision. Learn to work out more question papers just to figure out how do they ask these questions, because they are not going to change anything. It's just going to be a repetition now and again. So we're going to look into another question.